Hello everyone, welcome to lecture number 4 of our VMware NSX for Beginners lecture series. Now before jumping into the lecture number 4, let's just first understand what we discussed in our previous 3 lectures. So previous lectures we have discussed about why NSX, what are the issues with traditional networking model, and then we had a very introductory discussion on what exactly NSX is all about and what is the role of software defined networking to achieve a true vision of software defined data center. Now in this lecture, we're going to discuss about NSX architecture. We're going to have a little bit more deeper discussion on all the NSX components which actually combine together and give us NSX as a solution. So we're going to discuss about those components. So with that, let's get started. Now this is the NSX-v architecture. So before we jump into the architecture, I wanted to be very clear that this architecture we're going to discuss from the NSX-v perspective, and we'll see that at the end of this lecture how NSX-t architecture evolved as compared to NSX-v architecture. So we're going to discuss about both of the architecture components. So let's start with the NSX-v architecture first. So physical networking that remains the same whether it's NSX-v or NSX-t, the physical networking remains the same. As we discussed earlier in our earlier lectures, NSX does not rule out the requirement of physical networking. We still need a physical network. We still need the physical infrastructure as a transport capacity for packet forwarding, switching, and even the routing as well. So that's where your physical network is all about. Then you have the first component of our logical network. So now our logical network started, and the first component is the data plane. And data plane, as you could see, that it is the responsible for your VXLAN packet forwarding, switching, routing, and firewalling. So all these switching, routing, firewall capabilities is actually performed by the data plane component of NSX architecture. Now, when you look at this data plane component, as you could see that we have a distributed services, or we have a distributed switch which is giving us switching capabilities. Then we have a various kernel modules for switching, routing, firewall. Then we have NSX Edge, also known as perimeter gateway, and then we have a hardware VTAP. So all these components actually sits at the data plane layer of NSX architecture, and NSX architecture is considered to be a high performance data plane architecture as compared to your traditional physical networking, because it gives you a scale out distributed forwarding model. Every ESXi host is actually giving you switching, routing, and firewall capabilities, and that is the reason it is a high performance data plane with the scale out distributed model. The next component of this NSX architecture is control plane. Now control plane is responsible for all the control plane operations, and NSX controller is the responsible for the control plane functions. NSX controller is considered to be brain of your NSX architecture, because NSX controller are the one who actually manage your logical switching and your logical routing, and NSX controller are the one who actually maintains the entire networking state of your NSX network topology and pass that information to all of the data plane components. So NSX controller is the one, you could say that it is the brain of your entire NSX networking, which has a complete layout of your NSX switching and routing functions. Now it also get deployed as a 3-node controller cluster. So in the subsequent slides, we'll discuss a little bit more detail about all of each of these components. So let's move on to the next plane, that is our management plane, and NSX manager sits at the management plane. Now management plane, as we know that management plane is responsible for all the management related operations. It gives you a centralized configuration interface or REST API and a starting point to manage your entire NSX networking from a single pane of glass. So it is a single configuration portal and also a REST API entry point. At the last, we have another layer called cloud consumption. So cloud consumption layer is just about your self-service portal. So if you want to enable, if you want to have a IT enabled IT, or you want to have a self-service provisioning kind of implementation, then you can integrate NSX Manager to your self-service orchestration portal such as your VRA or your OpenStack, and you can integrate those solutions or cloud consumption model or orchestration platform with the NSX manager to automate not only the NSX component deployments, but also automating your end-to-end software defined networking, like configuring switches, routers, firewalls, and everything. So you can integrate the NSX architecture with your any of the self-service orchestration platform. Now let's go and have a little bit more deeper discussion about each of the layer of this architecture. So this is the data plane components. As you could see that your ESXi host, because in we are referring to NSX for vSphere architecture. So I will always be referring to ESXi hypervisor. So as you could see that ESXi node is a part of your data plane. Along with ESXi node, or along with your ESXi host, you also have something called edge nodes. So edge nodes are nothing. These are the virtual appliances which get deployed as a part of NSX architecture, and they perform and gives you a north-south routing capabilities, or they takes care of north-south traffic. And they also consider as a Swiss knife army, giving you lot many capabilities. So let's discuss about those. So when you talk about the ESXi, so ESXi, every ESXi host would be having a couple of kernel modules running in it. So one of the kernel module would be switching capabilities, another kernel module would be routing capabilities, and another kernel module would be a distributed firewall capabilities. So once these capabilities, once this firewall, or sorry, once these kernel modules get installed in your ESXi host, now ESXi host get promoted as a NSX data plane node to give you distributed switching, routing, and firewalling capabilities once you prep your host for the NSX architecture. Now, on the edge services gateways get deployed as a VM form factor, and they can deploy it as a primary, secondary, or primary standby kind of implementation to give redundancy. And this edge services gateway actually get paired up with your physical networking or physical network infrastructure. They learn the routes, they publish the routes, and that's how they bridge your VXLAN network to the VLAN back network. So they actually gives you a way to go out your packet from VXLAN boundary to the VLAN boundary. So that's how your NSX Edge Services Gateway considered to be as a Swiss knife army, which gives you dynamic routing capabilities, and it also gives you NAT, DSCP, load balancer, and all those capabilities. Now the next component what we have it is a controllers. So as we discussed, NSX controllers again get deployed in a virtual form factor. Each controller or each controller VM is having a 4 vCPU, 4 GB RAM, and they actually responsible for data plane programming. So NSX controller actually create a maintain the maintain the information about your VTAP table, ARP table, MAC table, and then basically it populates this information or programs each of the data plane node for the packet forwarding and packet switching. Now, the good part of the controller is basically it gives you a scale out distributed model where basically it gives you inbuilt high availability capabilities. And one of the most important thing about this control planes or these controllers are they eliminate the need of multicast support in your physical infrastructure. So before controllers, we need to have a multicast support in our physical infrastructure to support VXLAN packet forwarding. But with this controller implementation, it eliminate the need of having a multicast support with the introduction of unicast mode. And then it also gives you capability of ARP suppression, and with the ARP suppression it help us to reduce the broadcast traffic in our VXLAN network, and overall it improves your network performance. Now as you could see in this particular diagram, you have a ESXi host, these ESXi hosts connected with your controllers, and then whenever any VM which is sending any packet, that packet once get into your ESXi host, these kernel modules do some magic, and then they add an additional header called VXLAN header. So as you could see that once packet goes out of your ESXi host, it has its VXLAN header, and that VXLAN header is responsible for giving you overlay networking. So that's what your control plane is all about. And then we have a management plane. There we have a NSX manager which sitting at the management plane, giving us a single pane of glass or centralized point for managing your entire NSX networking. Now, NSX Manager in the NSX for vSphere, you might have observed that NSX Manager has a one-to-one mapping with the vCenter server. So you map your NSX Manager to the vCenter server, or you can also use VRA, OpenStack, or any self-orchestration platform, self-service orchestration platform, and you can integrate those platform with NSX Manager, and then you can pretty much automate this kind of configurations as well. So NSX Manager, again deployed as a virtual machine, it provisions and management of network and network services. So management plane or NSX Manager is not only responsible for giving you a single pane of glass for managing NSX networking, but it also helps you in deploying the controllers, preparing your host, or creating switches, routers from a single pane of glass. So that's what NSX Manager is all about. It also has a capability to have an integration with the third-party console, where third-party vendor can integrate with this NSX Manager and then give you added capabilities on the same platform. And then, as you could see that, you know, there is no dedicated UI for NSX Manager to manage your NSX networking. It gets integrated with your vCenter server, and with the standard vCenter UI, you can manage pretty much your NSX networking as well in the NSX V implementation. This slide talks about how each of these components, data plane, control plane, and management plane components come together and help us to deploy the NSX architecture. So as you could see that we first deploy NSX Manager, then we register this NSX Manager with our vCenter server. After successful registration, we go and deploy NSX controllers. Once controller implementation is done or controller deployments are done, then we prep every cluster of our ESXi host for the NSX capabilities. And once it is done, all our clusters are prepped with the required kernel modules for switching, routing, and firewalling. Then we go and deploy NSX Edge Services Gateway. This Edge Services Gateway help us to connect our VXLAN network to the external physical network. Now this is a pretty much NSX VUI looks like. So as you could see that this is the NSX Manager UI, and that's how pretty much your NSX Manager UI looks like. And this slide, as you could see that, your NSX Manager is integrated with the vCenter server, and it shows the status as connected. Now, as we discussed, now we took the NSX V architecture as a reference architecture, but now if you are really following NSX and following VMware on the NSX front, you might have seen that there's a lot of things about the NSX-T, and everyone is talking about NSX-T. Now there is a reason behind it. Now, if you look at the NSX-T, it also gives you networking, security, automation, and all the networking monitoring solutions what NSX-V was providing to us. But NSX-T gives you a lot more added capabilities which were not present in the NSX-V architecture. For example, it says that any hypervisor, NSX-V implementation was tightly coupled with the ESXi hypervisor, but now VMware extended the support of hypervisor from ESX to KVM also. So now NSX-T has a capability to not only support ESXi hypervisor, but it also supports workloads running on KVM hypervisor. So that is the extended support, which is present only on the NSX-T offering. Then it talks about the heterogeneous endpoints. So in the NSX-V, if you see that VMware was just supporting VM workloads. It means every single virtual machine workloads can be protected, can be leveraged NSX capabilities. But in the NSX-T, VMware extended this support to not only virtual machine workloads, but also containers and bare metal workloads. So now the endpoints have got increased with the NSX-T offering. Now another third point, as you could see that multiple clouds. So NSX-V offering, if you see that, it was pretty much for the on-prem deployment. All of the on-prem deployments were pretty much on the NSX-V implementation. But now as we are moving towards the cloud, we are moving towards the hybrid cloud era. So as you could see that all this support for cloud platform is only present in the NSX-T. So that is the difference between NSX-V and NSX-T, where NSX-T you can consider is the extension of NSX-V architecture. And then basically NSX-T has a lot more capabilities and additional capabilities to support additional hypervisor, more endpoints, more cloud platform, which was not there in the NSX-V. But when we think from a fundamentals perspective, we still believe the fundamental still remains the same. And just to prove that point, let's go and see the NSX-T components. So again, if you look at the NSX-T components, we have a data plane. Now data plane does the same thing. It does the packet switching and packet forwarding. But the only difference between V data plane and the T data plane is basically the number of endpoints. So NSX-V, we just had a ESXi host as a data plane components, but in NSX-T, we have a KVM, we have a bare metal server, which contribute at the data plane layer of NSX architecture. And not only that, it also has a support for VMware Cloud on AWS, offering Azure, AWS, IBM, and bare metal Linux and Windows VM as well. So that's what NSX-T has a wider range of support for all kind of workloads. But that was not the case with the NSX-v. But still, when you talk from the functionality perspective, the job remains the same. Every data plane component is responsible for packet switching forwarding. And that's what the job of data plane. Now, when I talk about the control plane, again, we have a controller cluster doing the same thing. Again, we have a controller cluster doing the same thing, giving us the same scale out and redundant model, maintaining and propagating dynamic state and network information, and propagating this network information to not only to ESXi transport nodes, but now they are propagating this information to KVM host, bare metal servers, and public endpoints as well. And at last, again, we have a management plane. Again, we have the same NSX manager, and NSX manager again sits at the management plane, getting can be integrated with your cloud management platforms such as Terraform, VRA, or OpenStack, or any other self-service orchestration platform. So this is also a UI and API entry point. It stores desired configuration and interact just like your previous NSX architecture. It also interacts with your control plane components, and also interact with your data plane components. So now the only difference, if you see that, in the NSX-v, if you're familiar with the NSX-v architecture, the NSX manager got deployed as a standalone VM. NSX controller used to deploy it as a standalone VM. So we were deploying total 4 VMs just to get our management plane and control plane. But now in the NSX-t architecture, as you could see that, what VMware simplified this architecture by combining NSX manager and controller into a single node, and they call it as a unified appliance. So we do not need to deploy NSX manager separately and controller separately. We just need to deploy unified appliance in a 3-node controller, 3-node cluster, and then basically we have a manager and controller right there available there. And that's what the difference between NSX-v and NSX-t architecture, where NSX-t architecture is a bit more simplified and have a extended support of wide range of workloads. So that's what pretty much about NSX-v and NSX-t and the architecture and the underlying components. We hope you enjoyed this lecture. Thanks for your time. Please like, share, and subscribe to our YouTube channel. Thank you.